Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this lesson is going to be the first introductory lesson on differentiation. So, to start with, we know that the gradient is, we have done this in coordinate geometry, that the gradient is given as y2 minus y1 over x2 minus x1, meaning it's the ratio for rise over run. So, the same concept of the gradient when applied to differentiation, we can say is gradient of the tangent at any point on the curve is the rate of change of y with respect to x. So, it's going to be the rate of change of y with respect to x here, the rate of change of y with respect to x, meaning if I write it in terms of differentiation, then I can say that the rate of change of y, it's given as dy, the rate of change of y with respect to x as dy by dx. So in differentiation, to find the gradient value or the derivative or the differentiation function, we will have to have the function dy by dx. So there are few notations that first we shall be knowing very well, and the rotations are that if the function is given as equals f of x, then the gradient function, then we can say that the gradient function here, the gradient function for this can be given as f prime x. So f prime x is actually the gradient function of y in terms of fx. Or in other words, if we have an equation which is simply y in terms of x, then we can say that the gradient function is actually dy by dx. Now the question arises, how can we have this gradient function? How can we have this derivative? We can call it the derivative, or we can say it's the differential function, or else we can say that it is the gradient function. So these are the few terms that are associated with dy by dx. So how to do that? Let's start. If you are given the function which is y, which is equals to x to the power n, then to find dy by dx, it suggests that to get dy by dx, I should simply multiply the coefficient of x with n, and then to the power, I should be having a minus 1, meaning the power here, meaning this power here, this index here, it gets 1 less, and then this power actually gets multiplied with x or the coefficient of x, meaning if I have here another example, if I have here y is equals to ax to the power n, then for dy by dx, I should say that this is going to be a times n gets multiplied, the power gets multiplied by the coefficient of x, and 2x, the power shall get reduced by 1 here. So this is how we do differentiation. So let's do some questions regarding differentiation. Number 1, find the derivative of, or find dy by dx. Part A, let's say it is y which is equals to x to the power 9. So in place of n, I have 9 here. So to get my derivative dy by dx, simply I'm going to say the coefficient of x in this case, the coefficient of x in this case is a 1. So 9 times 1 gives me a 9, and then x to the power 9 gets reduced by 1. And finally, I can say that my answer or my differential or my derivative function is going to be 9x to the power 8. Or if it is given as y, let's do another question. It's given as y, which is equals to 3x to the power minus 2. So to get the derivative, the rule remains the same. I'm going to say it's 3 times negative 2, and then x minus 2 gets reduced by minus 1. So the derivative dy by dx in this case is going to be a 3 times -2 giving me a -6 and x to the power -2 minus 1 giving me a -3. So this is how I shall be getting the derivative function here. Let's do another example. If your f of x is given as function of x, meaning it's y, which is a function of x, it's given as 4 by 5 x to the power 10. So the coefficient of x that I see here is a 4 by 5, meaning my derivative f prime x is going to be 4 by 5 times the power, which is 10, and x should get reduced by a 1. So 5 and 10, they get simplified by 2, and I can say that my f prime x in this case is going to be 2 times 4 giving me an 8, and x gets reduced by 1 giving me a 9. So this is going to be the example for f prime x. Let's do another example. F of x, which is equals to 7 by x square. So here I can say it's f of x, which is equals to 7 x to the power. I can take this x, I can take this x square to the numerator, and I know when I take this x square to the numerator, then the sign of the power changes to -2. So I have this equation. To get the f prime or the derivative, I should say it's 7 multiplied by the power, and x again gets reduced by -1, and my answer here then is going to be f prime x, which is equals to a -14 and x to the power -3. This is how simple this work is to get your derivative function. Let's do a few more examples. So let's say you are given y, which is equals to 12x to the power 8 divided by 3x. Now obviously we can simplify this y value, and we can say it's 12 divided by 3 giving us a 4, and then x to the power 8 divided by x can be solved as x to the power 7. So now simply I will be getting my dy by dx, and this will be 4 times 7 giving me a 28, and x here should get reduced by 1. So I can very easily say that my dy by dx here is going to be a 28 x to the power 6. So it's y, which is equals to -x squared times -3x to the power -5. So again, we need to simplify this equation first. And when we simplify the equation, this becomes negative into negative, giving us a positive. The negative and the negative here, both multiplied, will give us a positive. The coefficient of x square here is a 1. So 1 times 3 shall give us a 3. And then 2x, I should be adding the powers, simple indices here. So I will say it's y, which is equals to 3x to the power -3. So I have a simple equation in terms of y. Therefore, I can now differentiate it with respect to x, and I can say that this shall be 3 times -3, and -3 gets reduced by -1, or I can say it's dy by dx, which shall be equal to a -9 and x to the power -4. If your question is for f of x, which is equals to x to the power -4 and x square plus x to the power 6. So obviously, first thing is to get the equation in the most simplified form, and here I can say it's x -4, which shall get multiplied by x square, and then plus x -4, which shall get multiplied with x to the power 6, meaning the function equation can be x to the power -4 plus 2, and then x to the power -4 plus 6. So here my f of x shall be x to the power -2 plus x to the power 6 minus 4, giving me a 2. So here also we can see that there are two terms in the functions, and for these two terms I will be differentiating the two terms separately. so that my derivative function f prime x shall be equal to negative 2 x to the power negative 2 and a negative 1 plus 2 x to the power 2 minus 1. And then I can say that my f prime x is going to be a negative 2 x to the power minus 3 plus 2 and x. So this is then going to be the answer to this function. Let's do another one. Y is equals to root of x, square root of x plus 3 bracket times square root of 2 root of x plus 5. So here I can see the two radicals. So even with radicals, we can just differentiate the function very easily. It should be under root x times 2 under root x plus 5. I need a simple equation for this. Therefore, I need to expand the brackets and then plus 3 times 2 square root of x and a plus 5. So if I solve it, then this becomes 2 root x into root x, that's going to be an x, and then plus 5 square root of x, and then plus 6 square root of x, and then it's going to be a 15. So here I can see that my y equation can be written as 2x plus 5 plus 6, which gives me an 11 root x, and then it's a plus 15 here. So if I need to differentiate the equation, then with respect to root of x, I'll simply say this is x to the power 1 by 2, and then it's a plus 15 here. So whenever we have x to the power 1 by 2, then simply I'm going to differentiate the function as dy by dx. And to do that, I'm simply going to say it's the power of x here is obviously a 1. And the power of x here is obviously a 0. It's a constant in that equation. So just remember, whenever we have a constant in the equation, then after differentiation or in the derivative function, the constant gets eliminated. Let's start working on it to see how it is done. So 2x, meaning x has the power which is 1, so therefore this is 2 times 1, x to the power 1 and minus 1. So this becomes x to the power 0. Now over here, this is 11 into 1 by 2, and x to the power 1 by 2 should get reduced by 1, and here it's 15 times 0, the constant, it's the constant in this equation, and as I've said earlier, in differentiation, the constant here, it gets eliminated, and this is the reason that with this constant I can see that there is an x, but the power to x is a 0. And here we all should be knowing that any number, any digit to power 0 is actually a 1. So x to the power 0 is a 1. So with a constant we can say it's x to the power 0. Therefore this 0 gets multiplied with 0, giving us obviously a 0 value, or x, obviously it is getting eliminated because 15 times 0 is a 1. So this constant here gets eliminated because it's 15 times 0, which is a 0 here. So we don't even need to do this step. As soon as I see a constant in the equation, then I should know that in the derivative function, the constant should not be there, it should get eliminated. So this 15, it should get eliminated, and here I will only be differentiating 2x and 11 root of x. So let's get back to the differential equation that we were solving. So it was dy by dx, and here I can say this is 2x to the power 0. So there is another thing that I have seen here. Whenever there is an x in the equation, then this x after differentiation is left only with this coefficient of x. Meaning here if I say that if it is y is equals to x, then the differential function here shall be equal to a 1. X to the power 1, 1 minus 1 becomes a 0, and the coefficient here, we know that the coefficient here is a 1, therefore the differential function here is going to be just a 1 here. So it's 2x to the power 0 and then plus 11 by 2, and x to the power 1 by 2 minus 1 gives me a negative 1 by 2. 1 by 2 minus 1. So it's 1 by 2 minus 1 into 2 over 2, or I can say that this is going to be a negative 1 by 2 here. So this is one working which comes very often in this question. So here I should say it's 11 by 2 x to the power negative 1 by 2. The constant it was getting eliminated. Therefore, now my differential dy by dx is simply going to be 2 plus 11 by 2 x to the power negative 1 by 2, or if you want to write it the other way, you can say it's 2 plus 11 by 2 root of x. So this is going to be the differential or the derivative dy by dx for the given y function here. The next question is y equals 10x to the power 6 minus 3x to the power 5 divided by 2x squared. Now to differentiate this question, what we can see here is that there are two terms in the numerator and then there is this denominator. So unless and until we have the equation in a simple format, term form, we cannot differentiate this function for now. So what I can do is I can just simplify the equation by writing it as separate fractions as 10x to the power 6 divided by 2x squared minus 3x to the power 5 divided by 2x squared. Further, I can just simplify the equation and I can say that it can be written as 10 divided by 2, which is a 5, and x to the power 6 minus 2 giving me a 4, 3 by 2, and x to the power 5 minus 2 giving me an x cube. So this is a simple y in terms of x equation that I have. So to get the derivative or the differential equation, dy over dx, or the differential of y with respect to x method now is the same method that we were following initially. We'll simply multiply the coefficient of x by the power, and then to the power I'm going to subtract a 1. Here again it should be minus 3 by 2 into 3, and then to the power subtract a 1. So my differential equation dy by dx, or the derivative, becomes a 20 x to the power cube minus 9 by 2 x to the power square. So this is going to be the derivative of this equation y in terms of x here. Let's do another example. It's d by dx x to the power negative 1 by 2 minus 4x to the power negative 3 by 2 minus x to the power 1 by 2. So this d by dx means that this equation here should get differentiated with respect to x. I should be differentiating this equation with respect to x here, and I can see that all the terms that I have, they are all in terms of x. So differentiating this equation, I should simply say that this is going to be the coefficient of x here is a 1. Therefore, it is 1 times negative 1 by 2. So I'll be left with a negative 1 by 2, x to the power negative 1 by 2 and a negative 1, plus 4 times negative 3 by 2 and x to the power negative 3 by 2 and a negative 1, and then it's a negative 1 over 2 x to the power positive 1 by 2 and a negative 1. So solving it further, I can say that this differential now is going to be a negative 1 by 2 x to the power negative 1 by 2 negative 1 gives me a negative 3 by 2, and here I can say it's going to be a negative positive times negative, that gives me a negative, and 2 times 3, that gives me a 6. So it's going to be a 6x to the power. Now I have a negative 3 by 2 and a minus 1, which can be written as a negative 5 by 2. And then finally, I should be having here a negative 1 by 2 x to the power negative 1 by 2. So this is going to be the differential or the derivative of the given equation. Or if you want to write it in a proper index form, then I can also write it as a negative 1 by 2 x to the power 3 by 2 minus 6 over x to the power 5 by 2 and a negative 1 by 2 x to the power half, which can be written as an under root x here. So this is one form which I can get as the equation, or another, or to solve, like this form is also correct, this form is also correct. Also, I can express this as 1 by 2. X to the power 3 by 2, I can write it as x under root x. Because if I have x times under root x, let's change the color. If I have x times under root x, then it means it's 1 plus 1 by 2. And then this is going to give me x to the power 3 by 2. So this x to the power 3 by 2, I can also write it as x under root x. For x to the power 5 by 2, I can say that this can also be written as x square into x to the power 1 by 2, and I can say here that x square into x to the power 1 by 2 is also equal to x to the power 5 by 2. So this is x squared to the x square times under root x, that is also equal to x to the power 5 by 2. So here I can simply write my equation in more modified form as -6 divided by x square, square root of x, and then here it's already a square root of x here. So there are three forms which we can have for the derivative function in this case. So let's derivate the equation ax square plus bx plus c. So no problem. I know that the coefficient of x square, which is a in this case, should get multiplied by a, giving me a 2a. X square, that is 2 minus 1, that will give me just a 1. And then plus b, we know that the power of x here is a 1. B gets multiplied by 1, so this is 1 minus 1. Obviously, it's only left with a b, and we know that constant in this equation, after differentiation, it gets eliminated. So in this case, my final answer is simply going to be a 2ax and a plus b. That's it. This is going to be the answer to this derivative equation here. Another question that I have is for the function which is equals to square root of x minus x, the whole square, divided by square root of x. So I have the numerator which is to the power 2. So whenever we have this case, simply I should know that I will be applying the formula, the quadratic expansion for a minus b the whole square, which we know is a square minus 2ab plus b square. So if I apply this to this given function, then I can simply say it's f of x, which is equals to root of x, the whole square, minus 2 root of x times x, and then I should be having a positive x square. And we know every term should get divided by root of x here. Every term here should get divided by root of x so that we can differentiate this function easily. So solving this f of x function, I can say the first term left is just going to be a root of x. Root of x in the second term gets cancelled, giving me minus 2x, and here I can say this is x to the power 2 minus 1 by 2. So f of x then is going to be x to the power 1 by 2 minus 2x plus x to the power 3 by 2 here. So this is a simple f of x equation which we can now differentiate, and the derivative now is written as f prime x, which then shall be equal to a 1 by 2 x to the power 1 by 2 minus 1 minus 2 times 1, and x will be just x to the power 1 minus 1, giving me x to the power 0, which is a 1. And here I should be having a 3 by 2 x to the power 3 by 2 and a minus 1 here. So f prime x now is going to be a 1 by 2 x to the power negative 1 by 2 minus 2 plus 3 by 2 x to the power 1 by 2 here. So this is going to be my f prime, or my differential for the function given. Or I can also write it as 1 by 2 square root of x minus 2 plus 3 by 2 and square root of x. So again, put the forms here. They are considered the derivative function for the given function that we have here. So this is how we can do differentiation, and I hope everything is clear, and let's see you in the next video for another concept of differentiation. So best wishes to all, and see you all in the next video.